So let's look at an example of a hypothesis test of just a generic situation where the null says that the proportion of all individuals in the population that do something is 0.75, the alternative being it's greater than 0.75. So the first thing I would do is I would check and make sure it is normal. So normality, remember, for a proportion, NP has to be greater than or equal to 10, and n times 1 minus p has to be greater than or equal to 10. Well, in our case, p is 0.75, so 0.75 1250 is definitely bigger than 10. And 0.25, which is 1 minus that times 1250, is definitely bigger than 10. So we can assume the distribution is normal. And we'll go ahead and assume that it is from a random sample. It doesn't necessarily say that, but we'll say it's from a simple random sample of data from the population. So since we have this null of 0.75, if I want to find the p-value and test statistic by hand, it is a normal distribution. Remember, we assume the null hypothesis is true, and we want to figure out what's the chance that the sample is going to be what we see, which is 0.766 or greater. So we want this region, 0.766 or greater. So the probability or proportion of times this sample occurs is what we call the p-value. So if you want to do this by hand, we would first find the standard error of the distribution. Remember, standard error is p, 1 minus p over n. So the standard error is going to be square root 0.75 times 0.25 over 1,250. So I'll round this, so I get a standard error of 0.0122. So in this proportion, for a proportional test, we always use a z-value. So now we will use our standard error in our two values to get our z-value. So 0.766, pardon me, minus 0.75 over our standard error of 0.012. That will give me my z-value. And if I round that to 2 decimals, I get 1.31. So now I have to basically find the area above z of 1.31. So this is where I can use my charts. And again, I'm doing this all by hand. We can do the calculator as well. So if I go over here, 1.31 is going to give me 0.9094. So the area to the left of this curve is 0.9049. And so we want the area above it, so the p-value is above it in this case, so that is going to be 0.0951. So that's my p-value. So if this p-value is smaller than our level of significance, we'd reject, and if not, we would fail to reject. But that is how you would get your p-value. It is the probability of getting this sample, assuming this is true. Now, you can also do this on the graphing calculator, on the TI graphing calculator, don't forget. We could also use on the TI calculator series, you could use the one-prop z-test. And for the one-prop z-test, it asked me a couple questions. So it asked me P0. P0 in our case is 0.75. It is the proportion we're testing. And then it asks for X and N. So that's where I would put the how many out of how many. So the N is 1250. I don't actually know what the number is, so I'll have to do the 0.76 times 1250. Which gives me 957.5. So that is just our proportion of our sample. And then I'm going to put my hypothesis direction, which in this case is greater than. And so when I put all that in the calculator, it's going to give me that same p-value. So a couple different ways to do it. They both are fine, and they both give you same answer.